Welcome back. Today is day 4 of our similar triangles unit. We will be solving for the missing sides lengths of similar triangles. Hope you enjoyed the lesson. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. So again, let's see what we got here. It says, assume that the wheelchair ramp described each have a slope of 1 to 12. All right, so remember slope from a long time ago, probably back like in 7th grade. Rise over run. I put run first. So our slope is rise over run. So remember that from a long time ago, which means that ramp should have a rise of 1, so like 1 unit, for every run of 12 units. So that means if the ramp is 1 foot tall, then we need to have a run. It needs to be 12 foot long, all right? And that's the maximum slope. So let's try this problem. It says a wheelchair ramp has a 21-foot run. What is the rise? So the rise should be at, what should the rise be for this one? So let's try this. So let me see. We got our rise and our run. Remember when I'm solving proportions, I like to write out my ratio in words so that way I can see it. So I know I have the maximum should be a 1 to 12. And it says the wheelchair has a run of 21 feet. So that means this needs to be 21. And then we're going to solve for what should the rise be. All right, perfect. That's it. Now it's an easy, simple multiply your means and your extremes. One more time. So means, and let's go ahead and do that. That's going to give me 12x. And multiply the extremes. That'll give me 21. So equals 21. And then I just do a little algebra and you're done. So divide by sides by 12 and you're done. And x is equal to, let's see what the max rise should be on this ramp. So we're going to go 12 or 21, sorry. 21 divided by 12. And the answer is 1.75 feet. So for a 21-foot run, the highest rise that you should have is going to be a 1.75. You can have lower, that'll be fine, but you can't have more than that. All right, let's go to the next problem. So let's try one on your own. So on the same thing on this problem, I would go my rise and my run. And remember the maximum rise is 1 to 12. All right, and the wheelchair ramp this time says it rises 4 feet. 4 feet, and what is the run going to be? So the run should be here. So let's do the same thing. Multiply your means, which is 48, and that should equal your extremes, which would be just x, and it looks like x. So if your ramp is 48 feet long, it should have a rise of 4. And your ramp could be longer than 48. That's just the maximum. So if you have a 4-foot rise, you need to have, that's a pretty long ramp, in my opinion. That's long. All right, so let's keep going. You definitely need to check out this video. I'll leave a link in the description below, but watch this video to see why is this so important. All right, and this person explains it very well. All right, so let's try to solve some problems. So here's the problems that we'll be looking at. Recall that I told you the other day that I used like a kind of a step process. First, I identify what triangles are similar. So in this problem, I see 2 triangles. I see a smaller triangle and a bigger triangle. So I see triangle ABC. There's this triangle, and then there's the larger triangle of ADE. So there's that triangle right there. So there's 2 triangles here. Which ones are similar? First, I always write my similarity statement. So triangle ABC is similar to triangle ADE. So I do this first. This makes my life easier because once I have that, then I can write a proportion out with all my sides. So I can say AB, this is my step 2, to AD, and that has to equal BC to DE. And that has to equal AC to AE. Now remember, the reason I could do this is because we know the triangles are similar. And how do we know that? Well, we can do a little proof with like, this is a 90 and this is a 90 and this is a angle that's in both triangles. So we can say the triangles are similar by AA. So if you wanted to prove these triangles are similar, you can say, hey, these triangles are similar by angle, because they have two angles that are congruent to each other. Now the angles are congruent to each other, but that means the sides are proportional. So now we're going to use that proportion there to solve this problem. And this helps me out a lot. So now watch, let's do a little substitution. So AB is X, we got that. But here's where most students make a mistake. AD is from here all the way to here. That's how long AD is, that whole length. And that distance is X plus 2. That's the mistake a lot of students will either write 2x or they'll just write 2 instead of adding those together, because we're going to be this distance is x and this one is 2, so the total distance will be x plus 2. We'll have to add those two together. All right, but that's the mistake most students make. And then after that, it's pretty simple after that. So BC is 2 and DE is 3, and we don't know what AC is, and we don't know what AE is. Perfect. So in this problem, it makes your life easy. You know what proportion you're going to use. You're just going to use this one right here. This is the one we're going to solve. And now solving is going to be a little bit more work than usual because I have a binomial there. I have x plus 2. But let's do the same thing. Let's multiply our means together. So this will be, I'm going to write it out long way right now, 2 times x plus 2. And that's going to equal to my extremes. Let's multiply those together, and that will give me 3x. All right, perfect. So let's do a little algebra and solve this. So we have 2x plus 4, so I just distributed, which gave me 3x. I will subtract 2 from both sides of my equation, so subtract 2 over here and over here. That will give me 4 is equal to x. So we found out what x was. All right, perfect. Not too bad. A little bit of algebra that we have to do here, and we'll show you how to solve it on GeoGebra too. So again, remember, you could just take this equation right here once you have it and just use GeoGebra if you like and solve this equation very fast. All right, we're done. All right, let's solve that equation. So solve, and let's see here. X divided by x plus 2, oh my goodness, is equal to 2 divided by 3. Oh my, done. Game over. Let's try the next problem. So same thing. I would first state the triangles that are similar. So ABC is similar to triangle ADE. This is kind of easy because they're the same letters. And that would be by angle if you're asking. And then I can write a proportion out. So AB corresponds to AD, and BC corresponds to DE, and last AC corresponds to DE. Okay, step 1 is done. So remember, this is my step 1. I like to do this first, step 1. Step 2, then I'll do this. And step 3 is just plug in and solve. So now it is plug in and solve. Let's see how we do on this one. So AB is 4. AD is, remember, AD is from here all the way to here. All the way to here. So that's 4 plus another 8. So that's going to be 12. That's a mistake that most students make when they're doing this. And then BC, that's not too bad, is X. And DE is 12. Do we know AC? No, we do not. Do we know DE? No, we do not. So this makes our life a lot easier. We know we're just going to solve this proportion. So I'll do that quickly now. We should be quicker now. So 12x is equal to 48. We don't even have to distribute on this one. That was nice. They're nice to us. And x equals 4. Okay? All right, let's do it. Solve. What's my equation? 4 divided by 12 is equal to x divided by 12. Oh my lordy, so simple. Done. Not too bad. These are the advanced problems, but they don't look too advanced to me. This looks pretty simple. So let's try our last problem. All right, same thing. Same triangle, yep. Triangle ADE. And then write out my proportion, step 2. So AB corresponds to AD. And BC corresponds to DE. And lastly, AC corresponds to AE. And then after that, substitution. Let's figure this out. So AB is 2. Let's change it to blue. That's 2. AD is from here all the way to there. So how long is that segment? It's going to be the addition or the sum of those two. So it's going to be 2 plus x. We need to add those together. That's the mistake that most of my students make. BC is 1, DE is 3, and we don't know these two pieces. But it doesn't matter. We can solve this proportion right here. We can solve that one pretty quickly. So let's go ahead and do that. I am going to 1 times 2 plus x. That's from multiplying these two together. And then we're going to multiply the other two. So 3 times 2 is 6. And so distributing is not going to do much on this problem. Is every answer 4 in this problem? And subtract 2, and it looks like we are done with this one. So x is equal to 4. Nice and simple. These are the advanced problems, but I think we got the hang of it. All right, let's see if GeoGebra can solve this problem. Solve 2 divided by 2 plus x, which is equal to 1/3. Game over. Done.